Okay. All right, so you have your molecular formula. That's where you just have the number of C's and H's with the subscript. Structural is where you show all the bonds. Last one, I'll put it down here, is called condensed structural. This is called condensed structural. I want to say 90% of the time the Regents has you do just the structural where you show all the bonds, but sometimes you'll see the condensed. What the condensed does is it does not show the carbon-hydrogen bonds. So this one dash here, this one line between them, that's this one here, between the two carbons. All the CH bonds are condensed, so it's CH3 bonded to a CH3. So all three of these are literally the same thing. Just a different way to see it, different way to write it. Now, if I was to ask you, C2H6, is it an alkane, alkene, or alkyne? Then you would go to table Q. So, which one is it? Alkene, alkane, alkyne. C2H6 is an alkane, an alkene, or an alkyne? It's an alkane because it fits the formula CnH2n plus 2. The other way to figure this out, single bonds. All single bonds. If I had a double bond there, which we may get into today, that's an alkene. If I had a triple bond, that's an alkyne. Questions before we move on? Okay, one more thing before I get into these things called branched. Write this down. Alkanes are saturated hydrocarbons. What's a hydrocarbon, Morgan Thomas? Well, I think we wrote it yesterday in our notes. So just read it.
It only contains carbon and hydrogen.
Good. So you guys need to remember that. I've seen on the Regents many times, which of the following is a hydrocarbon? I mean, that's so easy. They shouldn't even waste their time with that question. You're just looking for the compound with only C's and H's. No O's, no N's, nothing else. Just C's and H's. All right. So anyways, wanted to review that with you. These terms, saturated and unsaturated. Yeah, you know what? I think we can do this pairing up. So, Courtney, why don't you come over here with Hannah, and everyone else pair up. One person come up and grab a molecule kit here. There's some over there you guys can grab too if you want. It's up to you. I just didn't want to drop it. That should be good. Do you have springs in there?
I have 2 springs.
That's all you need. Come on, Adam. You have to go over there.
Big, get big. Alrighty. Yes, exactly. That was my point. I loaded up the short answer and I just did it on the
Okay, look up here. I didn't tell you what to do yet. I'm gonna explain what these words mean. So, what's the name of this? How many carbons?
C2H.
2 carbons, right? 1, 2.
6.
So go to table P. What's the prefix? F. Now it's all single bonds, so it's called ethane. Now you could also go to table Q, look at the general formula, put 2 in for N, and you would get C2H6. Okay, this is the one we just drew before this. This is ethane. Okay. Are there any, can I add any more hydrogens to this? No, because each carbon has 1, 2, 3, 4, 1, 2, 3, 4, right? Because they share that one right there. Okay. By the way, so far, these hydrocarbons, right, just carbon and hydrogen, all the ones we've drawn, the homework, are they non-metals or metals? The atoms here. Where on the periodic table? Are they left or right of the staircase?
Non-metal.
Well, carbon is on the right, so non-metal. Hydrogen's here, but it's a non-metal. So if organic molecules, hydrocarbons specifically, are just C's and H's, what type of bonding does it have? Remember, there's 5 types of bonds: ionic, covalent, metallic, network, solid. Well, actually, the 4 types, and then there's polar, non-polar. But what type of bonding do you think this has? All non-metals.
Covalent.
Covalent, right. What did we learn about covalent? They're strong or weak? Weak. They melted back there with the candle. All the covalents melted. So organics are weak. They have weak forces, weak bonds, but they're covalent. Okay. So I don't really teach that. You've already learned it. Okay. But they're all non-metals here, so they're covalent. So that's just something you need to remember. All right. So this is ethane. What's this? Imagine that. This I can't get it to stay for some reason. This has a double bond. The springs are used for double bonds because the wood can't bend. So this is a double bond. This is C2U.
Ethene.
Ethene, right. It's ethene.
Shrub.
It's because the hole's too big, right? So this is ethene with a double bond. Ethene. How many hydrogens does this have? How many hydrogens total? 4. Okay. How many hydrogen here? 6. All single bonds, 6 hydrogens. This only has 4 because the carbons are double bonded to themselves. So there's double bond there. So what I want you to put in your notes, I'm using this as an example. So down here, go 1, 2, 1, 2, 3, 4. I know we just drew this, but do it again. This is what we call saturated, whereas this, so we're just drawing exactly what I showed you, is unsaturated. Is that a sneeze? Someone just sneezed? No? Someone coughed? Am I hearing things?
It was a laugh.
That was a laugh. Sounded like a sneeze. Okay, who's it gonna be? Sometimes I think it's funny when I look at somebody and then, we make eye contact and they look away because they don't want to answer. Tyler is staring at me, raising his hand. Nicole, can you tell me what you think saturated versus unsaturated means? Yep, that's it. Stop talking. Good job. I don't mean to be rude, but that's it. That's all I need to say. So this has the maximum number of hydrogens. I can't add any more. That's it. 4 bonds per carbon. 1, 2, 3, 4, 5, 6. That's the max. But if I take these 2 carbons off, hydrogens, sorry, these 2 off, and make a double bond here, now this is missing 2 hydrogens. So we call that unsaturated. So what this word means is it has the maximum number of hydrogens. What this word means is it does not have the maximum number of hydrogens. So you can literally count. This has 6, this has 4, this is missing a couple. Okay? So we need to write that down. So saturated means it has the maximum number of hydrogens. Good job, Nicole. So saturated, what the heck does that mean? Contains the max amount of hydrogens, H's. And alkanes are saturated, so I'm going to write this down because this helps some students remember. Single equals saturated. And what that means is if it's all single bonds, then it's saturated. It's all S's, single saturated. Single bonds mean saturated. If there's a double, which is what this spring represents, a double bond or a triple bond, then it is not saturated. Where have we heard that term in real life? Saturated and unsaturated. Solutions, good. That's more in here, but like in real life, not in this room. Fats, yes, who said that? Good, Nicole, on a rip here. Yeah, saturated versus unsaturated. Which is supposed to be better for you? Unsaturated. Okay? Unsaturated fats your body can actually use and break down. Saturated fats, a lot of them just sit in your arteries and grow over time. And then when you get older, if you're not healthy enough, it can block your arteries and you have a heart attack. So saturated, so like bacon, cheese, cheeseburgers, animal fat. Animal fat is saturated, not good for you. Some saturated fat, this isn't a nutrition lesson, but some saturated fat, like coconut oil, pretty good for you, okay? Olive oil. Anybody cook with that in their house? You should. Olive oil, lots of unsaturated fats, really good for your heart, actually. It's good for your body. This is the reason these fats are called saturated versus unsaturated. So unsaturated are better for us. So it's not exactly the same, all right, but it's related. So double, triple bonds here, single, not necessarily a good thing. Those are saturated. So single bonds are saturated. Some saturated fats are good for you, but most are not. But anyways, single means saturated, all right, and unsaturated is double or triple. You need to memorize that. And if I was to, don't write this, but if I was to do this, C4H8, if I wrote that and I said, is that saturated or unsaturated? How would you answer that question? Table Q, Colin says. Everybody do it in your head right now. C4H8. Go to table Q, see which formula it fits, and then you got to remember, single means saturated. Single means saturated. Esposito, what do you think?
It's
unsaturated. Unsaturated, right. You know what? Might as well write that down. This is unsaturated, and that's because it fits CnH2n, which is an alkene, and that has a double bond. If it has a double bond, that means it's unsaturated. We'll practice more of that down the road. I got to get to the branched alkenes now, but I needed to talk about that. So the bonding changes the type that it is, saturated or unsaturated. Again, that relates to the fats that we were talking about, so it's fairly relevant. And then on Regents, this is the hardest way they could ask that. If they drew the bonds out, if they did this, if they drew it out and they said, okay, which of the following is unsaturated, you would pick this one because it has a double bond. So unsaturated, again, would double or triple bond. All right, we'll practice more with that down the road. All right, so now let's talk about these things called branched alkanes. Okay, so I will have you put something together in a second. In your notes, I want left side, I want straight chain alkanes. And then on the right side, I want branched alkanes. Branched alkanes. When you think of the word branch or read it, what do you think of? Trees, yes. So here's how we're going to think about this. The trunk of the tree is called the carbon chain. It's also called the parent chain sometimes, the parent carbon chain or the main carbon chain. So that's the trunk. Any branches coming off of that, well, they're not part of the trunk. They're coming off of the trunk. That's why they're called branches. So we're going to take a bunch of carbons and link them together like we did yesterday, but then we're going to start attaching carbons to that chain. And that's what this is. So I'm going to give you two examples on the board here, and then I'm going to have you make them. All right? So let's do a straight chain alkane. So we're going to go 1, 2, 3, 4. All hydrogens, so copy this down. And then over here, we're going to have what's called a branched alkane. 1, 2, 3, 4. So I'll let you copy it down, then I'll explain what the branch is all about. And the branch starts changing the name. Okay, so the straight chain, 1, 2, 3, 4, 4 carbons. How many hydrogens? C4H, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It fits the alkane formula. Watso, what's the name of that?
It is butane.
Butane, very good. All right. Okay, here we go. Got a little more than 10 minutes, all I need. Focus here, best you can. So, 1, 2, 3, 4. Now, I'm going to put another carbon right here. And then we're going to circle that. And then we're going to point to it. That's called the branch. It's also called, there's three names for that. It's not really called a branch, but I'm trying to get you to understand the concept. So that's just like the analogy. That's also called a substituent, or it's called an alkyl group. There's only 2 substituents or 2 alkyl groups or 2 branches that you really need to know. Only 2. That's one of them. This thing is called, because it's 1 carbon, it starts with meth. And because the name of any branch is also called an alkyl group, this 1 carbon branching off is called a methyl group. So it ends with a YL. Methyl group. So the name of that is called methyl. That's one of the branches you need to know. I'll show you the other one in a minute. Okay, you and your partner, put that together. Put the branched alkane together. Put the branch together. You're making the branch. Stop playing with the springs, Mike. We're not doing those. We probably won't get to the springs till tomorrow.
Should we put the hydrogen on or not?
Yeah, for fun. Makes it look better. Put the hydrogens on. Make your branched alkane. Then I'm going to teach you how to name it.
Oh, we're gonna need one sticker. Yeah, just add one under the end, and then
What?
we'll add one end. Stickers there. And then just add one more under there. A bunch of hydrogens.
Then fill it up with hydrogens.
And what do you do?
Mike, that's pretty fast. Make sure you count up all your hydrogens. How many should you have? Check on table Q. You can check yourself.
Wait, what are we?
Check on table Q. How many hydrogens should you have? 5. No, that's carbons.
Oh, hydrogens. Let's do it.
It's all single bonds. 12. So, right. Should have 12 hydrogens.
Oh wait, there's 2. Okay. So the point of making it is just so you can see kind of, that's how it would look in real life, as far as the way that you can't draw or can't put it together in a straight line, even though we call it a straight chain, because that's how it kind of looks in like real life, the actual molecule. So, but now we gotta name it. So I drew a different one. You guys have butane, I drew pentane. 1, 2, 3, 4, 5. The reason I drew pentane in the notes here, you don't have to copy it down yet, is because pentane is C5H12. Well, this thing is also C5H12, right? If you count up all your C's and H's, 1, 2, 3, 4, 5. That's not called pentane. This is called pentane. So if you took this branch, okay, so So if you took this branch off and put it at the end here,
I think I know.
then it would be pentane, right? So if I took this off and I just added it here and it was a straight chain, that would be pentane. But it's not pentane because this branch is here. So you can see these four are kind of in a line, and then this one's sticking off. Again, that's the branch. Here's how we name this. I don't really write a whole lot of notes, I just show you. All right, and then you can see it, and that helps. And then we'll do a couple more practice problems. But that's what the rest of the homework due today is about, and then all the sheet due tomorrow. So when you have a structure with a branch, this is how I want you to do it. You circle the branch. You put a box around what's called the longest chain or the main chain. So how do you know where to put the box? It's the longest chain of connected carbons. So 1, 2, 3, 4 is the longest chain. Now I want you to look up here. I know you're doing something here, but look up here. I could have included this carbon in the box. Boxes can turn. They can take left and right turns here. Let me explain what I mean. 1, 2, 3, 4 with a carbon here. Put all the hydrogens on. So I could have done this. Why? 1, 2, 3, 4. This is still connected. So that is also part of the longest chain. Now this becomes the methyl group. And if you look at these two, they're exactly the same. So the way to name these branches, 2 steps initially. Put a box around the longest chain and then circle anything outside the box. Okay? So you circle this because it's outside the box. Why did I box this? Because that's the longest chain of carbons. Okay. Now, there's only 2 more things you need to do. Let's name inside the box. Forget that carbon's even there. What would it be called? Butane. How do you know that? 4 carbons, single bonds, it's an alkane. 1, 2, 3, 4. So inside the box, that's called butane, okay? We know 1 carbon as a branch is called methyl. And yes, you have to memorize that. You have to remember that or else you can't name these. So 1 carbon outside the box. So 1 carbon attached to the main chain is called methyl. Why is this called butane again? 4 carbons. Why is this called methyl? 1 carbon. You just have to remember the YL ending. Okay. Now, one last thing before we write the name. What number carbon is the branch attached to? It's attached to number 2. Number 1, number 2, number 3, number 4. Now, some kids want to say, well, isn't that also carbon 3? 1, 2, 3? Yes, depending on which way you count. You always go for the lowest number possible. You with me, Matt? So if I'm counting this main chain, numbering it, I should say, I go 1, 2, 3, 4. Why? Because 2 is a smaller number than 3. So if I go 1, 2, 3, that number's too big. I want the 2 instead of the 3. So this is carbon number 2. So now here's the name. You write 2-methyl butane. That's how we would name that structure. So the box, the box name there always goes at the end, and then your methyl group, your substituent here, always goes first, and then you have to label what number that is attached to. So obviously you didn't get it like right off the bat. Maybe some of you did, but let's practice a couple before we get out of here. Yeah.
So if there were 2 carbons outside the main chain, it would be ethyl butane?
Sort of. That's we're gonna do that next. Okay. I'll give you two more examples here. Okay. All right. So you can just stay together. We're not really gonna make any more molecules, but just stay in pairs here. So I'm gonna draw 2 structures. One here, one here. Copy it down. So draw these. I'm going to name them with you. And then hopefully we have time for me to give you a name and you try and draw it. Your homework is practicing this, so if you make a lot of mistakes on the homework, that's fine. That's what we're going to use to try and get better at this. Okay. I'm going to do the one on the right first. What's the longest chain of connected carbons? 6. Make sure everyone's up here paying attention, not playing with the models here. Okay. So, look up here. 1, 2, 3, 4, 5, 6, or 1, 2, 3, 4, 5, 6. I don't like making the bend, so I try and keep it straight if possible. Put the box around those 6. What do I do with any carbon outside of the box? Circle it. Now these two are connected, so I circle the whole thing. That's one bigger branch. This has 2 carbons. It's called ethyl. And that's the only other one you need to know. You need to know methyl, which is 1 carbon, which is a CH3. A methyl is a CH3. And an ethyl would be 2 carbons, and it's actually C2 and then H5. But that's an ethyl because 1, 2, F. All right, so now what do? We name inside the box. So what's the name of the structure in the box? 6 carbons, all single bonds. Hexane. So in the box, it's hexane. We know, so now we know the name. It's ethyl hexane, but we have to number the carbons.
3.
So 3. Very good. So this is number 3 instead of 4. We're not coming from the right. You can sometimes, but 3 is lower than 4. So the name of this is 3-ethyl hexane.
Isn't ethyl like an old lady name?
It is. It's also a substituent. And the old lady was young at one point.
Yeah.
Think about that. Okay. Longest connected chain of carbons. 3. You can go up and down or left and right. Let's go left and right. All right, now it gets a little confusing. Maybe, maybe not. Look up here. We circle this one, we circle this one. What do you call 1 carbon outside the box? Methyl. So that's a methyl, and so is this. What's the name inside the box? Propane. So this is called propane. What number carbon are both of those attached to? 2. Here's the name. Up here, pay attention. Watch me do it. 2, 2, dimethyl propane. It's actually not that confusing if you understand the boxes and the circles. Both carbons are on the second carbon, both methyls I should say. So they both get the 2. You have to write 2 twice. Each one gets their own number, even if it's the same number. What's di mean? 2. So you have 1, 2. That's where the dimethyl comes from. Propane is the box, the main chain. So on your homework, you're going to practice doing this. I don't have time to do it in reverse, where I give you a name, but the homework will help you practice that. All right? So I know some of you might be a little confused. Maybe the homework will help you, right? Help you learn as you're doing it. We'll go over those tomorrow. And that's it. Try and take those apart here quick before the bell. And that's it.
Oh my goodness, way to go. Jeez.